Believe it or not, asteroids are a big part of our lives even if we don't always see them. They are an important focus of scientific study because they help scientists with learning more about the origins of the solar system. Scientists study how often asteroids hit other planets and the effect of the impact on that planet. They use this information to learn how to predict them and what scientists can do to stop them from hitting the Earth. The first way scientists see how often asteroids hit other planets and the effect of the impact is by determining what causes them to strike in the first place. Due to the different gravity of each planet, asteroids all strike differently. For most planets, the pull of gravity is the same, but with planets like Jupiter, they can hurl asteroids out of the asteroid belt. Then the asteroid just flies around waiting to hit a planet. Since Jupiter is so big, it has the strongest gravity. This is the main reason that asteroids hit Jupiter the most. Then this happens again and again, which is the main reason that asteroids hit planets. Scientists can determine when they hit. They do this by looking at the updated pictures of planets and seeing if there are any changes to the topography of that planet. The way they see the strikes is by looking for any new craters on that planet. A crater is a bowl-shaped hole in the ground caused by the explosion of an asteroid. Scientists use the data they collect about asteroid strikes to help them predict a chance of a future strike. This is important because a warning could save lots of lives. There are lots of asteroids that are coming soon, but how do we know that? You can thank scientists for that. They can predict strikes up to 100 years away. Current ways for detecting asteroids on approach rely on ground-based telescopes with wide fields of view. These telescopes are very reliable, but they take longer than some other ways to predict asteroids. Another way scientists predict asteroid impacts is by using radar tracking data. Radar tracking data basically tracks all the asteroids near Earth. The NEO, also known as the near-Earth objects, are objects like meteors or asteroids that are close to Earth with a chance of hitting. NEO observers can more precisely determine the orbital path of an asteroid and predict that path years into the future. Radar tracking data is a lot faster than a telescope because it is online and more updated. Observing an asteroid for less than an hour with radar will provide a more precise orbit determination than months of observation from an optical telescope. The Near-Earth Object Wide Field Survey Explorer is one of the primary telescopes NASA uses to spot asteroids. Once the initial orbit is known, the potential positions can be forecasted years into the future and be compared to the future position of the Earth. If the distance between the asteroid and the center of the Earth is less than the Earth's radius, then a potential impact is predicted. The protocol for stopping an asteroid or comet headed to Earth is to detect it. The further away, the better. This suggests that NASA needs to expand its asteroid search operation. When the asteroid is still far from the Earth, the means of deflecting the asteroid is to directly alter its momentum by colliding a spacecraft with the asteroid. To prevent an impact, an object with a high mass could be sent out into space on a collision course with the asteroid, knocking it off course. This partly deflects it. The effect of an asteroid or wind blast, overpressure shock, thermal radiation, cratering, seismic shaking, ejecta deposition, and tsunamis. We should all be very thankful for the astronomers that study asteroids and the effects of their impacts. They could potentially save lives if an asteroid was coming to Earth. For more information, check out my blog.